Hi, everyone. So as you just heard, my name is Zach Bengtsson, and I am a fellow for the NASA Develop program. But I'm here to tell you about the dark, seedy underbelly of ecology, where invasive species wreak havoc on natural ecosystems and commit heinous ecological crimes. So there's an elite team of investigators that use DNA evidence to track and apprehend these criminals, protecting our marine, terrestrial, and freshwater ecosystems. And this is one of their stories. It's also one of my stories on top of that. Wait for it. There we go. I really wanted to use that Law and Order dun-dun, but it turns out it is very heavily trademarked. So unfortunately, I could not. But in all seriousness, some of the methods that we use when we're looking at environmental DNA or eDNA are so similar to forensic biology, we're essentially looking for the same thing. So I'm going to tell you a little bit about my time with the Nature Conservancy, sampling river ecosystems in the Lake Ontario region for environmental DNA of invasive fish species. So essentially, all of our work functions on the principle that you might know from a lot of crime scene shows. Every criminal leaves something behind, and in this case, it's just as disgusting as you might expect. So we're looking for things like decaying flesh, scales, feces, mucus. It's really gross, but it's super helpful to the ecology of an area. So we're looking at this free-floating DNA in the water, also that we can link an invasive species of an interest to a specific area. So there's that spatial component already built into what we do. So we start first by sampling ecosystems. We get water samples, we filter those on site, and then ultimately we take those into the lab so that we can test them for DNA of our target fish of interest. So once we have a positive result of a fish that we wouldn't necessarily expect to be in a region that we think is a really bad invasive, we focus our resources on apprehending a suspect. And this is really important for us because if we don't have that fish to essentially just flop on the table, we don't have those federal and state resources that we need to eradicate invasive species. So this process is not beautiful. It's a crime scene in and of itself. We do this a lot by electrofishing, where we essentially send electric waves into the water and kind of just see what floats to the top. Super scientific. But ultimately, from the project that we completed, we were able to find northern snakehead DNA in one of the main tributaries to Lake Ontario. And this is a huge deal because northern snakeheads are a terrible invasive species. They essentially eat everything, breed like crazy, and they're super hard to eradicate. But unfortunately for us, it was a cold case that we ended up closing just because we couldn't get our hands on the fish that we were looking for. And so this is really sad for us because it meant that we kind of just had to close things up and we didn't have the opportunity to do anything else. So fast forward to my time now working with NASA Develop. As you can imagine, my thinking has transitioned a lot to geospatial thinking and remote sensing. So this really got me thinking. Essentially, the origin of all of the geospatial analysis that we do on a daily basis can be linked back to searching for a culprit some 200, 300, 400 years ago. Definitely need to read a history book about that. With Jon Snow looking for the source of cholera and ultimately finding that it relates to the location of wells. So fast forward to now, this is a crime map of San Francisco. We use spatial data all the time for crime analysis. And as you can see, you're right there. I don't want to scare you, but keep an eye on your wallets. So this also really got me thinking that why aren't we using this frame of thinking when it comes to eDNA sampling and apprehending these invasive suspects? So we have remote sensing data, and we frequently use it to do habitat suitability mapping, and we don't really shift our frame of thinking about this from endangered species to mapping of invasive suitable habitats. So we can do this in the water. In our specific case, this would be looking at how murky the water is, what vegetation is there, what the algae content is, and we can also look at solar UV data to see areas where we can imagine that eDNA would be better preserved. And we can also do this on land. Which essentially means that we're also looking for just feces in the soil. Really, the sky's the limit when you're working with excrement because it happens to be everywhere. Another heads up. So when we're looking for our invasive species, we might be looking at a freshwater ecosystem like this. It's beautiful, it's scenic, it's a place that you might expect to go, has a lot of conservation resources because it's important for recreation. But when we're talking about an invasive species like the northern snakehead, we should be looking at a disgusting little swamp like this. So Northern snakeheads love this type of ecosystem. It's dirty, it's grungy, it's not the best place for eDNA sampling, but it's where we need to shift our focus. And if we use remote sensing and GS to target these locations on a landscape level, we can be better at finding these DNA evidences. So, I pose a question to all of you. Are you willing to cross disciplines and use your remote sensing skills to help us find a killer? Thank you.